5, welcome back to Tuesday's video, and our learning question today: can I compare and order fractions whose denominators are multiples of the same number? So this is a revision lesson again. We've done comparing and ordering fractions, but I think we just needed to go over where the denominators are different, because that's where we were tripping up a little bit. So I have got the two fractions on the board that we're going to compare, and I've got 2/3 and 2/9. And what you should notice first about these fractions is they have the same numerator. They've both got two parts of the whole referred to in the fraction, because that's what the numerator tells us. And I'm going to use a bar model to help show this, because when the numerators are the same, we need to look to the denominators to think which is the bigger fraction or which is the bigger portion. So who can remember the rule that I said last term about when we're looking at the denominators, who can remember that little rule? And I'm just going to use these bar models to help us show this. So I've got two bars here. I've split one into thirds and one into ninths. Now we can see nice and clearly here that when I split something into thirds, I get a much larger share or a much bigger piece of the whole, compared to if I cut the same hole, these holes are the same size, if I cut the same hole into ninths. It would be like if you were at a party and you were sharing a cake between 3 of you, so you each got 1/3 of the cake, or if there were 9 of you, I mean, no one's having a party of 9 at the moment, let's face it, but if you had to share a cake between 9 people, the 9th birthday cake slice or 9th cake slice you'd be getting is a lot smaller than 1/3. So I know before I've even shaded these that 2/3 is going to be a lot bigger than 2/9, and that is the rule. It's a little bit backwards, but the smaller the denominator number, the bigger the fraction or the bigger the portion you are going to get. So I know that 2/3 is bigger than 2/9 because the denominator, the smaller denominator, is actually the bigger fraction. So I've got another set of fractions here that have the same numerator. So pause the video now, see if you can work out which of these fractions is bigger. And so, like I said, we've got the same numerator, both got 3, but we've got 4 and 5. And remembering that our rule, that the smaller the denominator, actually the bigger the fraction. And you think about it, if I'm sharing something 4 ways or sharing something 5 ways, which way am I going to get the most or the biggest share? And you should say when there's 4 of you, you're going to get a bigger share. So 3/4 is bigger than 3/5. Okay? Right, and now I'm going to show you a little trick. It's a bit of a shortcut when we're comparing fractions, because it can be really tricky when the denominators and the numerators are both different. So this is a little trick, a little shortcut you can use. And what I'm going to do is I'm going to jot my fractions down here, because what you can do is you can multiply the opposite numerator with the opposite denominator. So we're multiplying across the fractions. So we're going to do 5 times 3. And what's 5 times 3? Is 15. I'm going to jot my 15 up there for sort of the value for that fraction. And then we're going to do the same. We're going to do 2 multiplied by 6. 2 times 6 is 12. And you always jot the little total above the numerator that you're multiplying by, okay? And it doesn't matter what way you do it, because multiplying, these facts are commutative. They work both ways. So 5 times 3 is the same as 3 times 5. Same with 6 times 2 and 2 times 6. And I just make sure that I put the little total here above the fraction that I'm multiplying the numerator of, okay? So I can see 15 is larger than 12, so 5/6 is bigger than 2/3. As I said, it is a little bit of a trick, a little bit of a shortcut, but hopefully it will help you to compare fractions when they've got different denominators. So pause the video now, try and use my little trick to compare these two fractions, and then join back in when you're ready for the answer. So I've got 4/10 and 5/12. And I'm going to do my multiplying. I'm going to start over here this time to show you that as long as you write the number above the numerator that you're working with, it works both ways. So 5 times 10 is 50, and 4 times 12 is 48. And these fractions are close because we've got 48 and 50, but we know, using our knowledge of place value and number, that 50 is bigger than 48. So 5/12 is bigger than 4/10. Okay? We'll do one more like this together, and then I've got some different style questions to test you with. So pause the video. Can you compare these two fractions? Which is bigger? And we've got 2/6, 3/8. I'm going to get my fraction. Can I do my 2 times 8, which is 16. And I'm going to do 3 times 6, which is 18. Doesn't matter which order you do it, as long as you put the total above the fraction of the numerator that you're working with. So we did 2 times 8, so the total goes above that 2/6 here. And my 18 goes above my 3/8 because we were doing 3 times 6 or 6 times 3. And 18 is bigger than 16, which tells us that 3/8 is bigger than 2/6. Okay. Well done if you started to use the trick and it started to get a little bit easier to compare those fractions. Now we're going to look at a sort of test question, how you would be asked to compare fractions in a test. And it says, here are 4 fraction cards. I've got 3/4, 5/8, 6/12, and 7/16. Now this is why all last term I was telling you it's really important to just know and recognise equivalent fractions of a half. Because what I'm going to start with in this question is think about comparing using my knowledge of a half. So can you spot a fraction out of the 4 cards we've got that is equivalent to a half? And you should all be able to tell me that 6/12 is equivalent to a half, because 6 is half of 12. Should have spotted that quite quickly. And now we can say, right, that is the same as a half. Using our knowledge of the simple fractions, sort of halves, quarters, thirds, can you tell me, is 3/4 bigger or smaller than a half? 3/4. It's bigger, isn't it? So that is greater than a half. Now we've got 2 fractions left, but they are 5/8 and 7/16. So now we're going to have to use our knowledge and understanding a little bit more. So I need to think, what would a half be equivalent to in eighths? How many eighths would I need to be the same as a half? And that would need to be 4/8, wouldn't it? 4/8 would be equivalent to a half. But I've got 5/8, so does that mean that is greater or less than a half, 5/8? It means that is also greater than a half as well. And what about 7/16? Let's think in our heads. We've got 16ths. How many 16ths would be equivalent to a half? What's half of 16? We know that is 8. So a half would have to be 8/16. But we've only got 7/16. So have we got more or less than a half if we've got 7/16? And it is less than a half, isn't it? Less than a half. Now we've compared all those fractions with using our knowledge of a half, we need to fill in, use any 3 of the cards to make this statement correct. And you can see that the symbol tells us that these 2 fractions need to be bigger than this one. So using the little jottings we've done, which is the smallest fraction out of my 4 cards? Which is the smallest one that we can put here? And you should all be telling me that the only one that is less than a half was our 7/16. So I'm going to put 7/16 in here. And then that was less than a half. So then I'm going to put our equivalent fraction to a half. I'm going to put 6/12. And then I can have either one of these fractions. And I'm going to put the 3/4 in there like that. There might be different solutions for that fraction, for that question. But as long as you've got 7/16 as the smaller one, you can have any combination of the remaining 3. Does that make sense how we use our knowledge of a half? One more question we're going to do together, and then you can have a go at the worksheet today. And it says, write these fractions in order, starting with the smallest. So we've got 6/5, 3/5, and 3/4. Now 6/5 and 3/5 we can compare straight away, can't we? Because they've got the same denominator. So is 6/5 bigger or smaller than 3/5? 6/5 is bigger. If you've got 6 of something, you've got more than if you've got 3 of something. So that is bigger. But what about the 3/4? So we can use our little trick here. We could say, let's compare it with our 6/5 and 3/4. So we can do our little multiplying trick. We can do 6 times 4, which is 24, and we can do 3 times 5, which is 15. And that tells us that 6/5 is much bigger than our 3/4 because that table's got 24. And then we know that 6/5 is bigger than 3/5 as well. So I'm going to put 6/5 in this position here as the biggest fraction out of those 3. But now we've got to think about, we've got 3/5 and 3/4. Now this is going back to what we were looking at the beginning of the video about when the numerators are the same. So can you tell me which of these fractions is bigger? 3/5 or 3/4? And you should all be telling me that the smaller the denominator, the bigger the fraction. So 3/4 is going to be our next fraction, followed by 3/5, like that. Okay? So that's how you would be asked to compare fractions in a test. That's the type of question they would ask you. And you've got to use your knowledge. You can use a little trick that I've shown you today, and using our knowledge of equivalent fractions and a half. So it all ties together when we're working with fractions. Right, I hope that helps you. Make sure you complete both sides of the worksheet. I know they're both 5, 5, 6, 6, but to complete both sides of the worksheet just to give as much practice as you can to doing comparing and ordering fractions. All right, see you tomorrow.